how to do the bonds with charges, like the ion.
Formal charges? Yeah, I'll do that now.
And then can we also go back over how to tell whether it's polar or non-polar?
Yeah.
Okay.
Because that's based on the structures, what they look like.
Okay.
And you can kind of picture it. Okay, can everybody online hear me?
Yes.
Okay,
Yeah.
okay. I was chatting with the class. Basically, a student asked regarding getting the test back. I have the test. They're all thing. I'll be glad to go with you, but it's department policy that I can't pass them back. That basically was not recommended because there's some faculty members that reuse them every year, whether the test bank or whatever else. And I don't care, but I'm not a maverick for the department, so I'm just going by what everybody else does. So basically, if you want to go over your tests, I put blank copies already online for you, so you can use them, take them again, and then check your answers for the multiple choice part and such like that, and see which ones you're getting wrong, and I'll be glad to explain them as well. But also, one thing that needs to be very made clearly is the 5 questions, 8 points each. Basically, I try very hard to give partial credit, and I purposely try very hard not to play favorites regarding it, because I don't even know who's getting the grade until I put in the grade book. So, because I grade them all together so I can see everything and be consistent across the board. So, and anybody that believes that I'm playing favorites or mistreating one student or another or whatever else or whatever, it's like I have things, particularly because many of you, because we're wearing the masks, I don't necessarily recognize everybody anyway because of that. So are there any questions regarding that for those of you distance regarding the worksheets you did over the weekend? I'm not really collecting them. Basically, they're just due so that we're ready to hit the ground running regarding finishing the last parts of the chapter. So do any of you who are virtual have any questions of me before we continue? Yes. Which ones? I give you credit for doing it. Basically, that was a worksheet exercise, and everybody's getting 20 points each for those that turned it in. Okay, because again, there's no way for me to know whether somebody worked with a group or looked it up or whatever else. The whole point was to keep people thinking within a certain time frame. Okay, and I don't really care whether someone used something else. It's like what I'm trying to teach each of you to do, and I know it's difficult, is to teach all of you to think like a chemist and put the steps together. And it's uncomfortable for some of you, but those of you who are athletes, many of you didn't come naturally. You have to practice to get really good at it. Well, same thing here. You got to practice to get good at doing something new. And those of you going into medicine, pharmacy, everything else, yes, there's some expectations that you need to get up to standards so you excel, and so people can trust you to care for their lives as well as put your life in their hands. So in some respects, many of you are starting on a great journey, and I encourage all of you to continue to it. And if you find you're not good at something, do something else that you are good at and enjoy, because part of college is learning to figure out what you're good at and what you like, and then go in that direction. Because some of you, when you're juniors and seniors, will decide to do something different. And the thrill I've had over since 1991 is those that have started it out as other majors and decided, I really like chemistry with Dr. Douglas or Mr. Douglas years ago. I want to become a chem major. Well, that's fabulous, because I had teachers that convinced me to do that too, because I was a bio major when I started. And then I found I just liked chemistry a lot better, and I didn't do well in zoology and botany. So in any case, any other questions? Okay, our test will be at 7 o'clock for group 1, except the athletes, you'll be at 8 o'clock on Wednesday. Is that okay? And so basically, those of you that came, come at the same time you came for the last one. And so it'll be 7 o'clock for the first group, 8 o'clock for the second group. It'll be the same format. You'll get a better periodic table with all sorts of formulas and everything on the back. So yes, we've got a department one that I'll be passing out with formulas and constants. And so basically that'll be provided for you. So yeah, you could put other things on your 3x5 card. But
Will you post?
Wednesday, huh?
Will you post like a copy of what will be given, like the one with all the constants and like periodic table and stuff on it, so we know like not to duplicate on our flashcards?
Well, the constants, you don't need to put them on there because the constants will be provided for you. They're on the card. So, and the periodic table, it's just a periodic table with constants on the back. So I could, it's just a thing, but I'll be glad to make a copy of it and put it online so you see what the back is.
Okay, thank you.
Or I'll make it better yet. I'll make a copy and email it to everybody. Okay. Any other questions before I start? All right. Now, what I'm going to do now is talk about is essentially continue where I left off, and basically, I do want you to understand this is all in context, and the barrier between Chapter 7 and Chapter 8 is artificial because different books go different places in it. And so what I decided to only have be on the test is not the geometry or whatever. We're essentially stopping with Lewis dot structures, which include resonance forms and formal charge. And the geometries and whatever will be covered in the next chapter. So basically that'll help you know where to go with that. Any questions on that regard? Okay, so let's start. Okay, I got to add an extra slide here because one of the slides is a mess, and I'm going to make it up and do my method with it. So basically what I'm going to start with is this one here.
Dr. Douglas,
Yes,
did you decide if the test is going to be on Wednesday or Thursday?
I just said that. It's going to be on Wednesday.
Oh, okay, great, thanks.
Yeah, Wednesday at 7 o'clock for group 1, group 2 for the others. I just realized I could do subtitles on this, so there'll be subtitles on this based on the voice recognition. So that'll help some of you if you want to do that. Okay, so let me share the screen with you now. Yes. Oh, sorry. Okay, can everybody see that now? Good, okay. All right. Can everybody see the screen? Okay, I'm going to share the screen with everybody. Okay, now, basically the Lewis dot structure of the carbonate ion. Basically, I kind of showed this with my own bad thing, but I'm going to do it again based using the next slide and do a couple other examples. So let me go for that one now. These are the number method. If you want to add them up and do it the method they do, feel free to do it that way. But again, I recommend you do it mine, just because it'll help you understand the three-dimensional aspect of the fact that these are real things, not just a set of numbers. So basically, let's start with a couple of examples, and these are what are called, let me highlight the slide. These are what are called resonance forms. Okay, an example of that is, for example, nitrate. Okay, and that's a very obvious one, but you notice it's -1 associated with this. So based on what we did before and where it is on the periodic table, what goes in the middle? Nitrogen. So we put 5 around it. 1, 2, 3, 4, 5, right? So where are the 3 oxygens going to go? Yeah, very good. Very logical. Okay. So here you form a bond. Okay. Another one, they go over here. Okay. And then another one down here. And you can kind of mix them together and put both dots. So now you have a -1 charge. So what does a -1 mean? You added 1 what to it? 1 electron. So essentially what we have now is 1 electron. Now, when there's a shortage of electrons on this oxygen, they're very, very electronegative. If it's short 1 electron, it's very electronegative compared to nitrogen. So where's it going to grab an electron? Where's it going to grab an electron from? What's nearby that it can grab an electron? The nitrogen, very good. So this one will go away. Now this has an electron and this one there. And so what happens then, these will then pair up and you'll end up with 4 electrons in the middle, shared. So now you have a structure that looks like this. And they spread out.
Dr. Douglas,
Yes.
would you mind re-explaining that? I didn't quite follow.
Okay, well, basically you start with the nitrogen, right? Brandon, you start with the
Yes.
nitrogen, correct? That has 5. Where do you put the oxygens?
Around the parts of the valence electrons that only have 1.
Okay, so you put 6 around each one, correct?
Yeah.
Okay, and then do it on the other one. Okay, so now you have 3 holes left. You have another one down here. So this one goes there for the other oxygen. So now you have 3 of them.
But the oxygens only have 6 valence electrons. So if you're pairing with nitrogen, that would only be 7 instead of
Well,
8.
what I'm saying is there's 6, yes, but the point is this is a -1 charge, right? So you're adding one electron. Okay, so one of the electrons is going to go here. Now this has a -1. This is called a formal charge. It now has a -1 formal charge around it because it got an extra electron. Now, this one over here also has a minus charge of -1, okay? Because essentially you have those because it stole one of these electrons from the nitrogen because they're very electronegative when they're short an electron. So it'll grab one from the closest available atom, which happens to be a nitrogen, one of the outer shells, okay? So it'll grab that from it, and then this extra electron here will bind up with that to give a double bond, and that's the structure that looks like this. You have a formal charge there of -1, this is a formal charge of -1, and this now has a formal charge of +1, but all of them have 8 electrons around it, right? Yes. Yes, and that's called formal charge. The book talks about it as formal charge because it essentially got an extra electron because it's part of an ion. Well, in this case, there's one extra on 2 of the things and then a double bond on the 3rd. Okay, and let me erase what's on the thing, and we'll give you another example with, I'll erase what other thing, I'll do another one with carbonate, Okay,
Dr. Douglas.
yes.
So, but with nitrate, would all of the oxygens get an extra electron or just one of them?
Just one, and the extra electron comes from the nitrogen, which gives it up happily to the things because it will form a double bond with another oxygen. And I'll show you with carbonate. Now, carbonate,
So will one of the oxygens have more than one, or more electrons than the other two?
two of them will, and one will have a double bond, but they all have 8 electrons around it. That's the key thing. So they're all pretending to be noble. Yeah.
So are you saying the 2 extra electrons on the nitrogen go to the other 2 oxygen? And that's why it's.
Well, let's just show you again with this, okay? And basically, again, I don't mind spending extra time with this because it'll be helpful. So we'll put down the nitrogen again, right? Like this. You have 5 around it, correct?
Yes.
They move all the time to available to be where they're needed most, okay? You have an oxygen over here, one there and one there. This forms a bond. This other oxygen over here has 6 around it. This also forms a bond. So essentially you have now 2 bonds there between the nitrogen. This one down here, you put 6 around it, this forms a bond. So now that's got an extra electron there. So you got 1 extra electron here, 1 extra electron there, 1 extra electron there, which is a lone electron. The whole thing is -1, right? So now you can put one of them here, okay? These electrons that are missing electrons, it only has 7 around it, correct? And so does this one. So one of them is gonna grab the extra nitrate from the nitrogen. So it'll go away from there and go over here to this. This now has a formal charge of -1. This has a formal charge of -1 because now they're using 1 electron. They got 1 extra electron from either the nitrogen or from the ion itself. Okay. The last thing, you've got this 1 electron here, this 1 electron there. That forms a double bond. So the structure looks like this. And then they spread out in a trigonal planar form. So essentially, you have these electron pairs sticking out like that around it. Now, notice the double bond is there, but it can also be in this way. You can also have a double bond here with the oxygens out like that. Where's the other place that the double bond can show up? Yeah, the oxygen on the left. So essentially, you can have all these different things here. So now the double bond can be there and there and there. And if you want to use the method that's in the book to do that, some students find that useful to do. But I encourage my students to do it this way, to just practice and move them around yourself, because it points towards what you're going to have to do with move electrons for organic reaction mechanisms and organic chemistry, for those of you that have to take it.
Dr. Douglas.
Yes.
Okay, so I understand that one of them is getting an extra electron because nitrate is a -1 charge. And then it's taking, one of the other oxygen is taking an electron from the nitrate, but then the third oxygen will still only have 7 valence electrons.
No, because it got one extra from the nitrogen, or it got 1 from the fact that the whole thing is -1 charge. That was
I know
an extra electron added to it.
But that's only 2, and there's 3 oxygens.
Well, I know. The -1 goes to one of the oxygen, which uses it up. So it now has 8 around it. The other oxygen grabs 1 from the nitrogen for itself. And then the nitrogen, that last electron, gets shared with the other oxygen that's also missing 1 to get a double bond. And that's the double bond uses it up, because these are 4 electrons for each double bond. But these are resonance forms. And really the only way you're going to learn how to do it yourself is to practice it the same way, using the different examples before. So let me do another example to show it a different way, okay? So basically this will just go to another example, and then you can watch the video again. So let's go to another example. Carbonate. Oops. Okay, we're going to do carbonate now. Carbonate, CO3 minus 2. Okay, where would the carbon go there? Okay, so you put a carbon there. 1, 2, 3, 4. Where do the oxygens go? Around each one. So you have it like this, and then 2 electrons there, and then another oxygen here, and you form a bond there, like that. And then another oxygen over here. And it form a bond there. Now, it's minus 2. And if you don't mind my asking you, Brandon, because you have the questions and are virtual now, notice these 4 electrons. What is the whole charge of the ion?
Negative
Carbonate is minus what for the ion?
-2.
Okay, so what does that say? How many extra electrons do you have available?
2.
2. So they can go 1 right here and 1 right here, right? That uses up 2. So now this has a formal charge of -1. This has a formal charge of -1. But notice there's 1 extra electron there at the top, this one and that one. What will happen to those? This is a little easier to see. Yeah, very good. So they now have 8 around it. But basically there's no formal charge. There's a 0 formal charge on the carbon. It wasn't necessary for it to borrow an electron from the like with the nitrogen beforehand. Okay, this one has just the carbon. So the carbon now has a structure that looks like this. And again, there are 3 different resonance forms where the double bond is there, or it could be a resonance form with the double bond being down here, and then a double bond, and then another double bond over here. So you have the carbon with the other double bond down here, like that. And the key thing is they're all around there. You can put the electron pairs, but I'm purposely leaving them off just so you can see how it works. But these are also resonance forms. So you have resonance forms associated with this. Now, that's a major part of that exercise 13, where it asked, do you have any resonance forms? Yes.
Is isomers going to be on the test or just?
Yeah, we'll talk about isomers in the next slide. Okay.
So resonance forms is like we can rotate the bonds just around the structure.
Correct. Because of things, because they're 3-dimensional, they rotate anyway. The key thing is what this will end up looking, and I'm going to delete what's on the slide and just show you how it works. Okay, I'm going to delete what's on the slide and show you how it works, but it's in the video. Essentially, what the nitrate will look like, oops. What the nitrate will look like will be this, NO3, like that. This is a formal charge of +1, this is -1, and this is -1 for the formal charge. You can put the electrons, the extra electrons in there as well. The formal charge in this is +1 for the center because one of the oxygens borrowed it. Then you have the electron pair over there, but this is also has 3 possibilities. So you have the double bond there, and then like that, and then down here. And then the other one would be nitrogen with a double bond down here, and then the oxygens like this. And the key thing is the real structure is where this double bond is shifting all around it. And so with the carbonate, it's the same thing. You have a double bond here, oxygen like this, oxygen like that, another oxygen like that, and the double bond shifts. So essentially, they're shared between each. So this is -2. This happens to be -1. They are all called trigonal planar. Okay, and basically they're trigonal. There's 3 of them. Okay, around. They're planar because they're kept flat due to the double bonds associated with them and the resonance forms. Okay. Yes.
So we do need to know molecular geometry?
No, that's on chapter 8, but there's an overlap, as I was saying before. that this is related to the other things. I don't like the barrier here is artificial in our book. Okay? As well as on the slides.
So on the test,
Just the Lewis dot structure and formal charge and resonance forms. That's it.
okay.
Okay? But
So
the trigonal planar just is a natural thing to add in there because it's three-dimensional. You can see what it looks like. It's flat. Okay?
Dr. Douglas, how would you
Yes.
ask for a resonance form on the test?
Sure, why not?
I said, how would you ask for it?
Well, write the Lewis dot structure for nitrate, just like in that worksheet, and put the resonance forms.
So,
All different forms that the
Yeah,
molecule can have.
yeah. Well, let me give you a sample problem. I'll erase this. Draw the Lewis dot structure for that. HNO3. And any resonance forms. This is a little easier. What do you put in the center?
Nitrogen.
Nitrogen. Okay, so essentially you have this, and then you put the oxygens next to it, like we did before. The other oxygen next to it over here. The other oxygen down here, like the extra. Where are you going to put one of the hydrogens? Where are you going to put the hydrogen? Yeah, good. One of the hydrogens goes here. So you have a bond there. Now, this is the same thing. This grabs an extra electron from the nitrogen, right? Just like the nitrate did. Grabs an extra electron from the nitrogen. So this electron goes here, shifts to there. Okay? You can draw the arrow in. That's good, highly recommended for those of you having to take organic. So this now, you have this electron and this electron, that'll pair to form a double bond. So the structure will look like this. Oxygen now with this and a hydrogen, and then down here you got a nitrogen with a double bond here. Now, Nick, what's going to be the other resonance form for this?
You can have a double bond for the oxygen.
Yes,
the
correct.
other one.
Correct. Yes, that's it. That's all. And there's still a formal charge here, and there's a formal charge of -1 over here. But now the double bond is there, and the whole thing is 0. Yes.
Is the other oxygen not double bonded as well? Like that, it took 2 electrons from nitrogen?
No, it just took 1. But remember, count all the electrons around the nitrogen. How many are there? Because you have a double bond and 2 signals. How many are there? You have,
3, 4, and nitrogen has 5.
no. You missed the double bond. There's 2, 4, 6, 8. There's 8 electrons around the nitrogen also. It just happens to be in the form of the double bond. Each line refers to a pair, correct? See, you have 2 here, and 4 there. So a total of 8. Okay, yeah.
Okay, so when you split the electron pair on the nitrogen, one acts almost like ionic, where you just give it over.
Yeah,
and make
it
bond.
gladly gives up one
Yeah.
because
And then
it's
the
going to
other
share
one-
with someone else.
Okay, and then the other, because that one is given up, the other one is shared with the other.
That's right.
Okay.
It's shared because it'll form a double bond with the other one. And when we get into hybrid orbitals, you'll understand how they all lap together. And that's in chapter 8. Okay?
Dr. Douglas,
Yeah.
why can we have more than one double bond? Like, can we just put the other oxygen as another double bond to take care of it?
Well, there aren't 2 double bonds. There's only 1. But the point is there's 2 resonance forms. What's the other resonance form? I'll use the other slide. I'll erase some of this. What's the other resonance form for this structure? What's the other resonance form for this structure? Well, the other resonance form will be like this. Double bond over here. With this electron pair there and there. And then this oxygen down here. 1, 2, 3, 4, 5, 6, like this. With a -1. there, a +1 formal charge here, and then you got another oxygen up here with 6 around it, and then the hydrogen. So essentially, that's HNO3. So the 2 resonance forms are there, and then you put a double arrow between both of them. Yes.
So, what is the first one? I think nitrogen has 5, right?
Right,
So you're joining one of each oxygen.
right.
So then you still have 3 oxygens there. Then you join the H, you join the oxygen. So you say you can only have 1 neutron. So where's the rest of the
No, you start with the nitrogen, right? It's 5. 1, 2, 3, 4, 5, right? You have 3 oxygens that go around it. This is what you said. You form a bond there, and then another one over here, and you form a bond on this one with the electron there, and then another one down here with this, and it has a hydrogen on it, like that. See that? This has one electron. This also has 1 electron. It'll grab it from one of here. This electron will move over there. So this now is shared with this one to form a double bond. So these move down and form a double bond. All of these now have 8 around them. The whole unit now is 0 because this has a hydrogen on it. That's essentially what I was saying before. So again, I'm not, I'm not trying to confuse you when I say that what I'd like you to do is practice these, and you will be able to picture it when you practice and follow my steps, because it's about you learning how to do it for yourself. Okay, so did I help you enough with that? So what part are you missing? What part do you not understand? Could you describe it, what you're not understanding? Yeah, that is now has a formal charge of -1. This one now is a formal charge of -1 because it essentially this and the nitrogen in the center now has a formal charge of +1. That compensates for the question you're talking about. Yes, there's an extra, and the other one has a double bond on it. But the point is, the double bond could be on either oxygen, so they still are shared because the electrons don't care what atom they're around. They'll switch between them based on electricity, the flow. Okay? Yes.
For the test, like when you give us a molecule like hydrogen nitrate, there for an example, let's say, will you give us a charge on the molecule?
Well, it
Like, what I mean
depends.
is, do we determine the charge, if there's a charge?
Well, let me do this one. H2CO3. Is there a charge there?
Well, not anymore because of the H2.
Yeah, that's right. So basically, you put the carbon in the same as before. 1, 2, 3, 4. Put the oxygens around it. Form a bond there. Another one over here. Another one there. Another one down here. Okay. And now you put a hydrogen on this one. Another hydrogen over here. And now you've got 1 extra electron here and 1 there. What's going to happen? You get a double bond like that. Done. So that's H2CO3. There's no charge associated. That's easy. But there's no resonance forms because it's just one structure, which is the same thing. It doesn't matter. 3-dimensional will still rotate around anyway.
How do you know if there's a resonance form?
Huh?
How do you know if there is a resonance form?
If there are 2 possible places to put the double bond, like with a nitrate, there's 3.
But how can you determine that?
Well, just by doing it. Well, here you can have a double bond that'll go there, place number 1, number 2, or number 3. It could be all 3 places. That's just the resonance form. It could go on 3 different oxygens, the double bond. Yes.
So resonance forms only occur if there's a double bond.
Yes, and essentially when there's double bond and another one available to do it, because as I said with this H2CO3, there is a double bond, but there's only one. There's no other place for it to show up because the whole molecule will rotate anyway. So it really doesn't matter, because essentially if you form the double bond over here, the hydrogen will just go over here. It's essentially the same molecule, that's all. Okay? So now we get into the next thing, which is called isomers. And I'm going to erase what's on the slide now, and we're going to talk about isomers. Isomers. And the first one is called constitutional, and that's the only one we're going to worry about for this class. You'll get into geometric and other ones. I will mention it briefly in this geometric and stereometric and other things. That'll happen more in organic, but you might as well understand what constitutional one is. And basically what I'm going to do now is give an example of CH2OH, or we do it C2H5O. And I ask you for the structures for that. C2H5O, if you've got that listed down. So let's just start with the first one. Where do you put the carbon? In the middle, right next to the other one. So you put 4 of them around. Then you put the other one next to it with 4. You then form a bond there, correct? Okay, how many spaces for the oxygen are there? Sorry, how many spaces for the hydrogen are there? So you can put the hydrogens around it. There's 6, okay? Okay. So, oh, no, sorry, CH3. So essentially we have to do that 6, put 6 there. C2H6O, sorry. Okay, there's 6 possible places to put the things, but there's also an oxygen there. So you put the oxygen next to it with also there, and essentially, so here you now have this, and there are, you put a hydrogen there, and a hydrogen there, and a hydrogen there, and then a hydrogen there, and a hydrogen there. So that is one structure, okay? That's called ethanol. This is called ethanol. Okay?
Wait, but you
Yes.
have 6 hydrogens though.
No, we have 6 hydrogens. 1, 2, 3, 4, 5, 6.
I thought it was 5 hydrogens.
No, I made an error.
Oh, okay.
I got the C6 up here, sorry. Your teacher made an error. This is a 6. Okay, this is a 6. C6, C2H6, okay? The other possibility, yes, you had a question.
Would you want the oxygen in the middle?
You could do that. That's another example. So if you put a carbon like this, then an oxygen next to it, then the carbon over here, then you have this as a possibility. And this is called a constitutional isomer. They're totally different compounds. They have different reactivity. They have different physical properties. They're totally different, but they're called constitutional isomers.
Okay, so if we gave one but didn't give the other, but it's still for like.
Well, if I ask for the isomers, then give both.
Okay.
But with this, there's just 2. Okay, 2 isomers. But you'll run into this in organic. I just want you to know the definition of isomer because that's in the textbook. Yeah.
Isomers are just different ways to arrange.
That's correct. And usually when I'm asking for that sheet, there are possible isomers, and that's why I put on there. When it asks for isomers, you say no, or if there are, you see, is there a possible way, another way to orient them on the thing? Okay? So
Dr.
now let's
Douglas,
look. Yes.
what exactly is the definition of an isomer?
Well, there's 3 possibles, but basically the definition, and again, I'm not one to remember dictionary definitions for the words, but the way I understand isomers, it is the same constituents of the different elements, but a different rearrangement of them.
So
It's
what's
like
the
if-
difference
if-
between that and a resonance form?
The
Because they're all
resonance form
different.
have to do with multiple or one double bond that could shift and go different places. And let me give you an example of this, okay, that will answer both of your questions. So I'm going to erase all what's on the slide and then put up another example, okay? So let's do C6, oops. C6H6, okay? So what's the first thing you could do to make C6H6? Yeah, so put the carbons like this. 1, 2, 3, 4, 5, 6. And then you'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So you have a possibility of 14 places they can go. But how many hydrogens do you have that are there? Let's see, you have 3, 5, 7, 9, 11, 14. You only have 6 there. So if you were to just line them all along, it wouldn't work very well. Okay, so we could start by putting one here, then one on the other side. How many do you have left? 4. So you could put one here and one here, okay? So there's all sorts of possibilities you could put it. You could also put one here and one here. Okay, now you have an extra pair there, an extra pair there. What's going to happen there? You could get a triple bond that'll use them. And here you can get a double bond. Is it still C6H6? Yes. It's just rearranged different, but you can move these all around. So there's all sorts of different structures. This is just one of the isomers you have. So where's another isomer you could put it? Where's another isomer can be? Yes.
Would that also be considered a resonance structure?
Perhaps. Perhaps another structure will have more, and I'll show you another example. Another example, and you'll learn this at organic, is you put the 6 carbons like this. Carbon, 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 carbon in a ring. Okay? Then you have 6 hydrogens around it. Okay? You then have an extra electron around each one. So there's an extra electron there, 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 and there, and there. So now you get a double bond here, you get a double bond here, and a double bond there. So the structure will essentially look like that with a double bond, and then down here, and then essentially one there, and then the double bond like that, and this is called benzene. But basically there are multiple things that you can have it. You can either have the double bonds like this with the double bond there, or you can have it like that, and that's also called the resonance forms. But that involves three double bonds all ordered. So again, it's just a matter, but they are isomers of each other. This one, number 1 and number 2, number 1 and number 2 are both isomers, but they're totally different compounds. Okay, now let's look at the next slide. 2 possible structures for formaldehyde. Okay, that's one structure for formaldehyde. You put it in electron pairs, one there, electron pair there, electron pair there. What's the problem with that structure?
C doesn't have 8.
Yeah, the C doesn't have 8. It just has 6 around it. So basically you put the hydrogen here, and now this one shifts, and then you can have this electron pair here, and then this will form a double bond. So the structure of formaldehyde looks like this. But there are no resonance forms because there's only one structure of it. And the key thing is this again is to try and get it most compacted because this will be unstable because there's only, it breaks the octet rule on the left. Yes.
So for that example, there's no resonance forms, but those two are isomers.
Well, the one on the left isn't possible because it's too unstable. Because it'll only have 6 electrons around the carbon. Remember, you want to have 8 around it. Because how many are around this carbon now? 2, 4, 6, 8. The other one won't be stable. It might be temporarily in there, but it won't be stable. So it doesn't really exist. Okay? But that's the problem you run into when you do the numbers like they're doing in the thing. Because essentially here, these are the 2 possible possibilities here. And again, this is why I teach the other method. There are 2 possible skeletal structures for that. The formal charge is the difference between the number of valence electrons there. And so essentially they add them there with the numbers like that, with the half number of bonding electrons. The sum of the formal charge must equal the charge of the molecule on the ion. And again, that's using their number method, which I, in a way, don't want students, because what I'm trying to do is prepare you for organic chemistry coming up.
So will we need to know how to find the formal charge?
Yeah, and I'll give you practice to do it. There's plenty of practice for this at the end. And this is an example here of doing the formal charge for the atom and the Lewis dot structure on these slides here. So basically, you can see the formal charge associated with each of those. But I don't want to distract you on those, okay? But that again is the structure for that. Okay, any questions? Yes.
Just real quick. Exactly what chapters will be in the test?
5, 6, and 7 on the test. And we'll stop with the Lewis dot structure, resonance forms, and basic isomers. And you can finish filling out the rest of that chart today. The geometries, don't worry about that. You can do the other ones just to practice it. Any other questions?
No, I'm good. I was just gonna
You don't need to give it to me. You don't need to give it to me. Just practice with it.
No, this is for the lab, the origin of color matter.
Oh,
I'm
yeah,
in
this
group
is-
2.
huh?
I'm in group 2, so I don't come tomorrow. Could I just turn it in?
Yeah, just put it outside my box right
your
when
box?
you're going by there, and I'll get it in a minute. I just got to shut down now. Okay, I'm going to end the meeting. Anybody still have any questions who's on the virtual? What?
Yeah, what do you think is like the most important thing? Study test, obviously, I know whatever we can do.
You need to turn off something, Kelsey. I can't hear you because there's a feedback. Yes, you had a question. If you want to give me something, put it outside my thing. So, Kelsey, did you fix your thing? You can email me your question, okay? So I'll stop.